Hi everyone and welcome. So in this video I'll be going through how I recreated the Gameboy version of Tetris as a GPU particle simulation in Unreal Engine 5's Niagara. So let's first start with a quick gameplay demo. So as you can see, it's Tetris. You can do all the Tetris things, move pieces left and right, rotate pieces, you can drop pieces, and you can make lines like such. And on the right here you got counters for keeping track of the level and the line count and the score. And when you've completed 10 lines, it increases your level by 1. And yeah, it's fully playable. Sometimes it bugs out. Yeah, that happened there. I don't know exactly why, but like one piece in 50 just kind of disappears. I can't debug that. Alright, so game over triggers, it starts again, resets the level. That's basically it. So in the level here, everything's in the Niagara Tetris blueprint, like this. Otherwise, it's the standard like game startup map. And if you look in the blueprint, there's a bunch of meshes and boxes for the case. I have a glass screen in front with a glass material, and then I have a sound source using Metasounds, and then we have the Niagara particle component, which renders the game. So let's come back to that, but let's look through it, kind of what assets we have in the game here. So go left to right. So there's some input assets using the enhanced input system. So you got input actions for down, left, right, and for rotate. That's mapped in the blueprint. We got a couple of Niagara functions that are saved here. These are the bigger ones. That's like draw Tetris piece is its own function, and the draw rotation shadow, which I'm using to keep track of if a piece can rotate or not. Let's go through those a bit later as well. In the sounds, we have Metasound sound source, and then we have the music, so the melody. Let's have a look at this one now. So what I did here, I basically drew the melody using the pencil tool in MSPaint, and then I'm reading the render target procedurally and playing it back through Metasound. So you got 3 tracks here. On the top here you got the melody, so this is the and so on. And then I got the bass here, this is like an octave bass thing. And then the bottom track here is the drums with like a snare and a hi-hat. Yeah, and then the Metasound one. I'll be going through that as well. In the starter content, I only have a shape cube because everything is basically cubes. The side is a cube, the glass is a cube, the particles are cubes. I should probably have made a plane, but I did not. And then in the textures here, we have here a bunch of textures for the digits for the number that it's using to render the digits. So they're baked together in a put together in a texture array that I can call. So this has at index 0, it has the texture 0, at index 1, it has the 1, so I can call it with an integer and get a texture back, that kind of thing. Same for the piece materials, like the materials that is actually rendering the individual pieces with, like that's this one, and that is that one. It also has an index, and then the pieces themselves, the shape of them. So these are 5x5 textures. All of this is done in MSPaint, by the way. It's the only piece of software I have. And the texture array for that. Then background, like that. And then a mask for the actual LCD screen pixels that I'm using as a mask in the materials. You can see if you go close here, it's masking out individual pixels from the mask here, and that's this one. And then there is a color curve here for the screen. So if I wanted a different color scheme, I can switch these out. And then there's a bunch of materials for the background, for the pieces, for the text. I probably could have parameterized all of those in a single material, but uh, I didn't. They're pretty simple anyway. Like the background one here, it just samples the background texture, it samples the pixel texture, it maxes them together, samples the color curve, sets a bunch some roughness, and just multiplies the emissive um, to get it balanced with the lighting. And that's all there is to it. Piece and text materials are similar, with the addition that they also sample the texture array. They sample the UVs with XYZ, and Z is the texture index. So here I'm multiplying by 7, so I can sample like 1 to 7 to get the different materials here. And the same for the pieces and the digits. They'll be in the particle system, so I'll go through them later. And then there's the particle system. Let's wait a bit before going into that one. That's where all the magic happens. Let's look a bit through the blueprint first. What's in here? This is what's in the blueprint. So up here we have the input. It's mapping the left-right axis, mapping the up-down axis for rotate and lower down, and yeah, that's pretty much it. And then I have the sounds being triggered here. We'll come back to this, but this is a Niagara particle data export blueprint. So all the sounds are being triggered from the particle system. So based on the particle data, it's using this blueprint interface that's implemented here, Niagara particle callback handler, to trigger and play the sounds. And then here, mapping the input, setting an object reference for the blueprint export for the particle data that's being used here. And then here is where it's reading the music render target. So I'm creating a render target with the same dimensions as the texture. Then I'm drawing the melody material on the emissive channel to it. And then I'm reading the target. And then I'm creating an array here with note values. And that's being added to here. And then I'm just sending in to the sound the notes as an array, and it plays it back from there, and then it starts playing the music. So that's really everything that's in the blueprint. So if we look at the actual particle system itself, it looks like this. Hold on. So that has the actual pixels being rendered. So what I'm going to do here is I'm just gonna turn everything off, and then I'll turn them on one thing at a time while I explain what's happening. So now we have nothing. If you look at the system level here, we have 2 render targets that's being created. So one for the board here, so that's 10 by 20 tiles or 10 by 20 pixels. And then one for drawing the next piece, so that's 5 by 5 to match with the piece textures I created. And then there's 3 simple integer counters for the score. So that's the score, number of lines, and the level. So these are being set here. And then the system state is set to loop once. So it just plays once, and then it doesn't reset here. So then in the background, it's just it's just rendering the background texture with the material, really. I could have done this outside Niagara as well, but I wanted it in here as a reference for the other things. So then these 3, or sorry, not this one, let's do that later. These 3, level, lines, and score. So these are pretty much the same. It's just keeping track of different numbers. So here it's rendering 6 particles that are like 8 by 8 pixels each on the textures. So each number can be 6 digits. Spawning these 6, 6. Initializing the particles, so each of them are at a different offset. Setting scaling a bit. But really the only custom logic is here, the color for the particles. So it's setting the color based on the digit value. So here it's checking each position. So this is the first position. So that's particle index 0 and then particle index 1. So it's checking. So this is an 8. So this is an 8 coming through here and it's dividing the 8 by 9 and packing it in as a float in the particle color because in the material for the text, it's the same as with the pieces I showed you. So here in the R channel, I'm packing the color value. So I'm multiplying that by 9 again. So it's a 0 to 1 range here. So like 1/9 would be 1, and then this would be index 1, and then it would sample texture 1, and it would render a 1 on the material, kind of. So it's doing these for position 1, position 2, and I'm manipulating the number just to get the number in that position. And here's the only custom HLSL I had to do just to get the log 10 of the number, which is basically how many digits. So a 4-digit number, log 10 of that would be 4. Yeah, so all these do is track these numbers. So if I set something for score here, it would just draw that number. And you can see it only does 6 digits. So if I do a lot of digits, it turns weird. It doesn't do all of them. Yeah, so that's those three. And then if we look at the main Tetris board, this is the big one. I'm gonna go through the next piece one as well, but that's being rendered from here, so I gotta start here. So let's actually turn all of these stages off and then turn them on. Cool, so now nothing's happening. So in the emitter here, it's same, it's starting once, same as the system, it's following the system loop behavior. So I have a grid 2D that's 10 by 20 and it's 100 world units per cell, so it's 10 by 20 with 100 units each, like this. And I have a texture array for the Tetris pieces. So that's the one I showed you earlier. So this is the loop behavior. It starts once, then it spawns 10 by 18 particles in a grid, because the Game Boy screen is not 10 by 20, it's 10 by 18, so it's only rendering the 18 bottom rows. So the top two here are not being rendered, but they're being used for calculation, so I can drop in a piece from above. And then there is a ton of simple counters. So this is the only data interface you can use between the CPU and GPU between simulation stages that I know of. So I have to use these to keep track of everything. If a piece should be placed, what's the Y coordinate of a piece, the soft drop score, like if you press down and place a piece quickly, it gives you more points based on how high you dropped it from. And then texture indexes for the texture array for the next piece and the current piece. Piece X coordinate, just check. I'm using this as a bool to see if a left-right movement is valid. For rotations, to keep track of how many rotations I made with a piece, to how it should render it. This is for scoring and row clearing, like the Y coordinate of a row to clear, X coordinate of a pixel in the row, row clear multiplier if you clear multiple rows at once, and then integer to keep track of like number of pieces played, like which piece triggered the row clearing. I'll get into that later. A counter for left-right input, like if you hold down the left or right key, it keeps moving the piece left and right, so I have to count that. And a freeze piece timer, which is like for if you drop a piece to the ground and then you want to slide it left and right a bit so it doesn't lock into place instantly. So I have a 30 frame timer here for that. A counter for the shadow tiles. So I'm using a concept called a rotation shadow. I made it up myself. So that's basically I'm drawing the piece in its rotated state to check if a rotation is valid. I'll go through that later. and then a counter for pause frames, like after a piece is placed or a row is cleared, it pauses for a certain number of frames. Then initializing the particle with a mesh here, 1, 1, 0 scale. Just I'm using the mesh as a plane. Again, probably should have made a plane. Setting the location of the. So this is like, let's see if I can. Yeah, so this is the particle grid here. It's invisible now because it's not being rendered, but that's the main game board. Particle variables for rotation, count, and x coordinate. I'm using these to calculate if a sound should be played or not later. Like way down here. But yeah, so let's keep going. So here, startup stage. So all of these simulation stages, they are iterating on a data interface, which is the grid for the current piece. So it's a 10 by 20 grid that renders the current falling piece, and I'm using the XY coordinates for that to calculate all of the other things. So there's a bunch of Scratchpad modules here that's being used in these stages. So the first one here is pretty simple. I'm just setting a random piece for the current piece and the next piece once on startup. So that's the shape of the piece, like 0 to 6. And this one calculates if a move is valid, but let's actually check this one. Yeah. First. So this draws the next piece to this render target here. So that it draws to the next piece render target. It draws the texture from the piece render array, and it gets the index of what piece to draw here. So I'm just translating the texture index for the render target, or from the texture to the render target, drawing it here with the correct Z coordinate, which is basically the index of the piece here. And then packing it is as between 0 to 1 for what index in the material. And then this one draws the next piece. It's a 5 by 5 particle grid here. And it has a function for next piece color. It just basically just gets the color and draws it. And then it's rendered with the material, and the material keeps track of what piece material to draw on it. And as the next piece render target here updates, this one just renders it. Pretty straightforward. So, okay. So then let's check this one. So you can see here, there's some previews here. So this one is a preview of the next piece render target here. So that's what it looks like. And the grayscale is because of the different colors for the different pieces, like what materials to draw. So yeah, so this one is the same. So if I just recompile here, you can see it's changing the next piece and it's changing the current piece. As you can see, the color intensity is different based on which piece it is, which is how I keep track of the materials again. So just recompiling. So now it's just drawing the grid, which is like how the calculations are done behind the scenes. And if I turn on this one, so this one handles the input and the movement of the pieces. So now the pieces are falling. I just compile. Okay, maybe it doesn't work. Okay, I gotta resave it. Yeah. So you can see a piece is falling here. So the texture coordinates are inverted. So this is the piece, and this is the piece in its rotated state. So if I resave this, you can see this like here. It's a falling piece and a falling piece rotated. So this one has two modules. So it has this one. So now is where it starts getting complicated. So this handles the input. So you can see I have the left-right axis from the user parameters here, left-right axis and up-down axis. And then I have all of the counters, and then I have the tick count to calculate the speed the game runs at, how quickly it drops the pieces. So first one keeps track of the soft drop score counter. Like if I start pressing the down button, it keeps track of when I pressed it, and then when the piece drops, it calculates my score for dropping the piece. This one resets the left-right press when I let go of this one, like the left-right counter, how long I press the key. This calculates the x coordinate. It's a bunch of bools. It needs to keep track of like how long I pressed the left-right input key for, and it needs to keep track of whatever this thing is. Yeah, if a left-right move is valid, it needs to keep track also of this thing here, which is if the game is paused or not. And I can't remember what this one is. I was pretty good on refactoring the other ones, but I think I kind of forgot this one. Yeah, I did it slightly here, just spacing out the gets. Yeah, so that's the x coordinate, and this is the downward coordinate. So it basically, if I press the down key here, it drops the piece one step every 3 frames. Otherwise, it calculates based on this equation, which is based on the level, which means that it gets quicker the higher the level is. Checks a bunch of other stuff, and then it sets the y coordinate of the piece here. And then this is how long I pressed left to right key for the left-right input, and this is for the freeze frames, like if I drop a piece and then want to move it after I drop it, I can do that for 30 frames before it locks. And this is the pausing after the piece. So all of these timings and stuff happens here in this input scratch pad. And then I have the draw rotation shadow like this. But this is the same as the draw piece, which I'm going to go through. It's just that this does it rotated, so I'm not going to go through this one. We're going to draw next piece instead. No, wait. This one. Yeah. So let's check here. Yeah. So this draws the actual Tetris piece to the board. So it gets the piece texture, the texture array index. It checks if should place piece. And actually, let's back up and check that one first. So this one checks if a move is valid up here. So like it's looking if a placement is valid down or if there's anything in the way when placing the piece. So the thing is you can't really like iterate through stuff the same way you would do in Blueprint. So all of these calculations happen like for each tile in the grid in parallel, basically. Although there is an execution index that keeps track of like what pixel it is. But still, I have to do this. So there's no concept of like a Tetris piece as an object. I have to do it for each square in the piece and then aggregate the results. So for instance, this one checks if a piece should be placed here. So it's checking first, like for every, in this one, for every tile that has a color in this, so these 4 tiles, it checks, did this tile reach row 0 in the bottom of the board? If so, place the piece. Or is the piece one step below colored in the persistent one? So this top one here is the persistent board state on a render target. That's using a green color to separate it out. So it's just checking green channel, one tile below, is this occupied? If so, place the piece. And this one sets the counter to 2, which is the same, like, is it one piece below and I'm above row 17, like row 18? So the top of the board and I collide with the piece, that means game over. So 1 means piece placed, 2 means game over. And this one checks if a left-right move is valid. So it's checking the same, like 1 step left and right on the board? Is there a piece in the way, or am I at the edge of the board? Like that. So if you go back to the draw next piece here, no, wait, sorry, draw Tetris piece, yeah. So this one, so if it's placing a piece and execution index is 0, this basically means that I do this once every frame. Because remember, all of this is done for each each cell in the grid, each frame. So this is the first cell. So it means, so I'm using this for stuff that is only done once every frame. So this is first, it's checking the freeze piece. So if the freeze piece counter is, or if a piece should be placed, yeah, it's subtracting from the freeze piece counter. And then I'm using that to check here, freeze piece. It does nothing until this one goes down below 0. And then it starts executing stuff because of this bool. Yeah, so if the piece should be placed because it's landed and the freeze counter is 0, then it should place the piece. So then it checks all of that stuff over here. So all of this is basically, it takes in the coordinates of the piece, like X and Y coordinates of the piece in the board, and then it samples the texture for the piece, and it combines like the rotations, it maps the texture index of the board. Here's where the rotations come in. So I'm calculating a quaternion based on like each quarter rotation, and then I'm sampling the texture here with the right XYZ coordinates for the right index of the piece and the right coordinates. And then this is basically a clamp sampling, so it doesn't repeat the piece, stamp it like on the board. And then if all of that is true, like if the piece is gonna be placed on the board, it draws it to the render target, like the persistent render target. If it's not placed yet, it just draws it to the grid, like the red thing here. So now it draws it to the grid here, and then you see when the piece lands here, it goes to the persistent board, like that. So that's basically all of that. Next thing I need to go through is the rotation, how that's handled. So that's pretty tricky here. So you can see here that this piece is drawn with 4 tiles, and this one is only drawn with 2. That means that, yeah, like that, it's trying to draw all 4. And this one, yeah, it's just drawing the piece the same, but I add +1 to the rotation. So it's the same as the draw piece thing we just went through. And then this one samples the rotation shadow board and sums up the state of all the pixels on the board. And if it can draw 4 valid pixels, meaning that none of these are outside the board or inside one of the green pixels here, then that means that it's possible to rotate the tile. And then it also checks, like, am I pressing the rotate key? If yes, it adds 1 to the rotate counter, which is just sampled here, so I can actually rotate, and then, yeah, that's how it's done. Okay, and then after that, I need to check if I have completed a row. And how I'm doing that is I'm using the tick just to separate so that I'm checking like 1 row each tick. So if there's 20 rows, I'm checking the bottom row and then the next tick 1 row up, and then it loops every 20 ticks. So for each of these rows, I'm just adding to the X counter if the tile in the green here is filled in. And if there's 10 filled in, that means that this row is full, and I can set the row Y coordinate to be cleared here. If it's not set, it's -1, so that's how I'm checking that. And then that goes to the clear row and score function. So this one, yeah, it clears and it scores. So first it checks the soft drop scoring, calculates like, okay, when did you start pressing the down key and when did you place the piece and how many points are you getting? And then this next function calculates your score multiplier, like how many rows did you clear at once? Did you clear one line or did you clear 4 lines at once? Gives you more points. And then this just sets the global counters on the system level so that they can be rendered here. And then here is where it actually clears the board. So it just takes in the hello? Is it working? Yeah, okay, my headset turned off. Sorry about that. Okay, so yeah, so this is where it clears the rows. It takes the where is it where it's checking that? Oh yeah, that's coming from here. The y coordinate of the row to clear. It just checks is it if for each pixel in the oh yeah, it's actually using this. It's a third one here. There's like a temporary storage for clearing the rows, and then when that's calculated, it draws it back to the render target. So it's using called board color. So if the y coordinate of the tile is above the clear counter, it just it moves everything down one step, so it just eliminates that row. And then it later here it draws it back to the render target. Yes. And then we have color particle here. So this one draws all of this information in the debug targets out onto the board. So now we can actually see stuff. So that just samples the both this one, the grid, and the render target, and superimposes like the state of both onto the board here, what you can see. So it's a bunch of color sampling and stuff. It also does some things with the sound. I'll come back to that when I go through the sound. And then at the end of the frame, there's cleanup. So first it copies this the clearing row grid back to the render target. Just simple sample each pixel, copy back to render target. Then it checks if there's a game over. So is the piece place counter, is it 2? That means game over. So it resets the score and resets the levels and stuff. Otherwise, there's this function that basically resets all of the variables after each frame. So some of these, like the input counters, I think, and some other things. Wait, what's this one? Yeah, like the temporary variables, they're being cleared each frame. And the stuff over here is just being cleared like after a piece has been placed. So after freeze piece counter is 0 and piece placed counter also, this one, then it resets all of this, like the y coordinate of the piece, so it's at the top of the board again, and all of these counters. And then it goes back up to the top for the next frame. So it starts here because the set random piece is only once at the start, so it checks if the move is valid, draws everything, and just does this 60 times each second, and then you have a game. So the next thing here is the sound. So I'm using a particle data export interface here. So I have 3 values here. So it's using the particle color, variables for like move sound and rotation sound. So these are being calculated here in the color particle. I have for each particle, I have a rotation count and an x coordinate. And then from the simulation, I'm reading in rotation and x coordinate. So if it checks if they are the same. So has rotation increased since the last frame, or has the x coordinate increased since the last frame? If yes, then it says play rotation sound, play move sound. So they're being exported here. Particle data export, I have a callback object here is a user parameter, and this one I can read from the blueprint. Yeah, I think that's everything in this particle system. So let's go through I think the last thing to go through is the sound, how these are being played. So let's open the blueprint. Yeah. So here I have the particle data that's coming from the callback that we just looked through. So I have for each particle in the Tetris grid, I have these parameters. So it's just checking, should I play a move sound? Should I play a rotation sound? Yes. And what it does for the piece drop and the row clear sounds is basically just counts the number of tiles on the board and compares that to last frame. So if the number of tiles has increased, then a piece has been placed. Place the piece drop sound. If the number of tiles has decreased, then a row has been cleared. It plays the row clear sound. I can also play a game over sound here, but I just didn't make the sound yet. And all of those sounds are here in the Metasounds. So I'm not using any samples. All the sounds are being generated here in the Metasounds thing. So first, I showed you earlier the melody and the melody material, the render target that's being fed in as a note array. So these three here, that's the music. So there's like a BPM counter, it repeats, and then each time it repeats, it reads the next value from the notes target. And I'm filtering out like which notes belong to like every third note belongs to the melody, or every third index belongs to the melody, every third to the bass, every third to the percussion. So all the sounds are being generated here with like translating this mid to MIDI notes and then to frequencies and doing some things with them. And the bass here, percussion here. All of it is being combined with a mixer to the output. And then here are the sounds. Each of them have their own triggers, like piece drop sound is being generated here, row clear sound generated here, move sound, and rotate sound. And most of it are being like bit crushed and downsampled to like Game Boy sound quality. And balanced here and to the output. And I think that's all of it. Went to this, went to this. Yep. All right, video done. Thank you guys for watching. Feel free to reach out to me with any comments or questions if you have them. And have a good day. See you around.